Hello, this is a video, a continuation of videos about P90 and P 1 year and 10 years. Now if you look at the slides, I think I've got some slides somewhere on renewable energy. They're zipped. Okay, now if you go to the let's look at the resource assessment one. Okay, I'm discussing the P90. Now, there are these wind studies, of course, and there's this annual variation in the wind. This is the historic variation in the wind for the UK, for example. You can see it got 10% below the average and 10% above the average. And there's some more wind analyses, and there's some issues with long-term trends in wind forecasts. And then you can simulate these winds with a Weibull distribution, which I'll show you how to do in the next video, in some kind of video. And then you put that together with a power curve, and you get just how the wind goes up and down, okay? This is how much I love the PowerPoints. I go about this fast through them. And then there are all these other uncertainties, icing, and that's what's in the 10-year stuff. And they tried to demonstrate it here that this is the kind of wind can go up and down, but this 10-year has a permanent effect, and it can come from this mass accuracy, this wind shear, this turbulence intensity. That was the word I was looking for. Oh my God. Okay, and this correlation, wake effects. Okay, there's some availability, variability, and okay, all this kind of stuff. And this is the big criticism of wind. This is the P90 down here. The P50 is the top one, and the actual is below the P90 in every single case. These consultants didn't get it right. That's essentially what this chart says. They should just say it. Of course they didn't. Now what I'm going to do is kind of work through a little some of these things here. Okay, and let's down here compute the standard deviation for the 10-year. Okay, that we can get. Okay, and I think we'll compute it, and it should be the same for all of these. Okay, now if we want to get the standard deviation for the 10-year, I'll just say, let's just say we put 10, and let's just go across here and put them in all of these. I'm going to stop there. Okay, now then we put a goal seek. How's that? So what we're going to do is make a goal seek and see, well, okay, if we put in the standard deviation and we put in 95, I think we put in 5%, right? When we did this simulation, yes, we take 1 minus this, and then we put in 10%, 25%, and of course 50%, which doesn't matter. Okay, and then if we put NORMINV, that's the only thing you really need to know. And then you put in this probability, let's put it like this. Okay, and then the mean is just the P50, and I just press the F4 a couple times, and the standard deviation is this. Okay, and it gives you this. Now, if you take this that we've computed, so if we get 10 years, we look at this, it gave us the right one for P50. But these, it didn't quite give us the right number for. So if we take this minus the number, let's lock that in, we can get the difference. Now, uh-oh, sorry about that. I should have put this turbulence. Well, I remember turbulence. Okay, now, let's see if I can, did I make some mistakes to copy this across? I'm sure I did. Okay, I guess I didn't need any dots there, did I? Excuse me for being such an idiot. Okay, now these goals, what we're going to do is just change this to make sure this goes to 0. Now, I want to do the goal seek over and over and over again, so we'll make a macro on the first goal seek, and then I'll probably pause it and make a little, and then we'll just make a little for loop to go around the row and the column and do it again and again. Okay, I've done it, and I should have practiced it and all this. So I'm just going to call this goal seek. Okay, and then what we do is we just go to our data, what if analysis, goal seek. Let's set this value to 0 by changing this one. Okay, and I think what I'll do is make a little range name for both of these. Okay, so that's the answer. This is the standard deviation now. Okay, and now it should be the case that the standard deviation stays the same all the time. Okay, so oops, and I didn't turn off the macro. I committed the big crime. Okay, let's call this range the standard STD10 because it's for the 10-year case, and let's put this as the goal for the 10. Okay, and then what we can do is go to our macro. I won't waste a lot of time on the macro here, hopefully, and I'm leaving it on just for a minute. Okay, and we don't need the rest of this stuff. Okay, and essentially we just go for, let's see, row equal, and then range, and we put, remember, the first thing was we put STD10, and then what you can put is dot rows dot count. So that'll go around the, did I spell it wrong? Range for 1, 2, excuse me, got ahead of myself a little, didn't I? Okay, and then you can put for column, and just change the run this to call. Okay. Okay, and then we're going to go around, and each time we're going to let me just say that this is range. This is the goal seek. Okay, and this is goal 10, and we put dot cells, row, comma, call. Is that what it was? And then we put range here. What was this? STD10. put next call and next row. So here's what I'm going to do. I'm going to turn off the macro because it probably won't work. I know you're not going to believe me, but it worked the first time. I can't believe that. I love it, actually. Now, we're going to do the same thing now. And the very interesting thing here is that these are very consistent standard deviations. And if we want to do a little more analysis, here's what I suggest we do, is we put standard permanent deviation relative to the P50 case, or the mean. So, so we'll take these, since everyone except this one is something really funny going on. So the first thing to do is ask the consultant, what in the heck's going on? Why is this different for the different cases? But I'm just going to take the first one and divide it by the P50 case. Okay, and here's the real kicker. And maybe we don't like this one, but this one has 12% standard deviation for the permanent factors. Now, it could be maybe I'm giving an enormous benefit of the doubt here. Okay, I'm putting the capacity factor here. Okay, maybe when you have a lower capacity factor, okay, we get A. So this one, we have a high capacity factor. They seem to put less permanent in. But look at this one. This is the really high one. This has got a pretty good. What's the difference here? 2 times as much factors. Is there 2 times as much? And this one has 16% compared to this one. Tell me that somebody can figure out the deviation. This is the thing I didn't say enough. Tell me somebody can figure out what drives these permanent factors. This is just such crap, frankly, that this is just so different than this. This comes from different judgment about how the correlation, the wake effects, everything else is affecting. This is not some scientific analysis of the wind from a NASA satellite, or, well, not even a NASA satellite, from a good MetMaster or something like that. Now, what I'm going to do is do the same thing, but this time we're going to do it for the 1 year. And remember, the 1 year has everything in it. So I'll put 20, okay? So we'll do the same thing. I apologize for the length of this video, okay? And then we'll put the goal seek, okay? And we'll do the same sort of thing. All right, and how about this? Since I've already done it, I'm going to pause the video since it's getting a little long. Okay, this time I'm going to try it with you. So we find the rows. I named the ranges. So we found the number of rows and the number of columns, and then we set I put another range name for 1 instead of 10, and 1 instead of 10, and then let's just make a little macro here, okay, and try this. So it's just amazing. Sometimes things work. My life hasn't been working today, that's for sure. God damn it, I'd call Microsoft because I really believe there's a bug in this Excel 2016, and they reinstalled it, and then the bug appeared immediately. And so remember, this standard deviation includes both the 10-year and the 1 year. And remember, this was all screwed up. So this includes both the wind variation and the permanent effects. This is what I can't emphasize enough. Now, the thing you cannot do is, let's figure out how much just comes from the wind. Okay, so this is the total deviation. So we can now put just total deviation. Okay, and then in a minute we'll put just the deviation only due to the. I've got to change the title here, of course. This is the total deviation. Okay, for me, this tells me a little bit more. Okay, and then we can put our capacity factors in here as well. Okay, so we've got deviations that range from 26% to 16% to 13% to 11%. You can see that the deviations for this permanent factors are probably bigger when we got a 2 times difference here, in this case. Look at this enormous difference. Okay, now what I'm going to do this time is recall that if we take the 38, this equals this 38 equals we can take this this one, okay, and then we square it. Okay, and then, whoops. Okay, and then we do the same thing with we square it. Okay, and we can take this one and square it. Okay, oops. And we take this minus, whoops, the other way, this minus this. Okay, and then we take this and raise it to the 0.5 power. And that gives us our deviation that's just due to the wind. So you can, to prove this again, well, I don't have to do it really. We did this. Take the square. This is the square of this. This better be the square of that one, okay? Alright, and then if we sum them, we get our same thing. So we've kind of proved that this one. So what I want to do is put just the standard deviation here of the one here. Okay. Or no, sorry. Standard deviation. Now what I really hope of the wind effect, I wish that some of you bankers, if any bankers watching you, criticize, get into these studies and don't be afraid to use the norm inverse and start questioning this stuff. Okay? It's obviously got a ton of judgment in. If you give me a minute, I'm going to pause and just do all this. Okay? Okay, so here's the formula. You just take the total squared minus the permanent squared, and you take the whole thing and raise it to the 1/2 power. Okay, so we put this here. I suppose I'll leave this stuff here, and we can go down and go across. And this last one we're going to have to do. We don't get any information from that. So this is just the wind speed effect for the 3 different cases. Again, we have something odd going on in this last one, which we should ask the consultant about, and then we can compute the wind deviation, and that should, well, I thought it's going to be about, I don't know, I would guess 8% or something. This looks like it's going to be more like 10%, which is maybe fine. Okay, and that's kind of what I used in my little example. Okay, so let me see, we got 11%, 10%. 11. These are more consistent, except a weird outlier at the end. Okay, so these were consistent, but the permanent thing wasn't consistent, and this is where all the judgment comes in. Come on, this is availability. How much uncertainty is there in the wind, the wake effect? How much uncertainty is there in turbulence? How much uncertain? It's not measuring the turbulence. It's not measuring the availability. It's not measuring the met-mast errors. It's not measuring these things. It's how much uncertainty there is in these. So I think that's enough of this one. Goodbye. I'm going to continue with this stuff.